All right, guys. Good morning. First, we're going to go over the assignment from yesterday. So let's start right at the top. All right, let's go through this. Make sure if you have any questions, you email me. It's bryan@archbishopcurley@gmail.com. And any assignments that you're sending in, make sure you send them to my school email, bryan@archbishopcurley.org. All right, cool. So let's go over this. Difference of squares. Complete the following rules. So these are coming right from our charts from our notes. All right, so difference of squares. A squared minus B squared. All right, so if we have two perfect squares that are being subtracted, we have to find A. So it will end up being A plus B times A minus B. I'm going to do my best with handwriting. I'm sure it will get better over time. Sum of cubes. Just remember in the formula we got to find A. Once we find A, we can plug it in to this A plus B times A squared minus AB plus B squared. And that's just given to us. We just need to find A and plug it back into that. Now, finally, difference of cubes. We have A minus B times A squared plus AB plus B squared. All right, and those are very similar, but it is expected that we have that memorized, so make sure we're getting that down. All right, how can you tell if you have completely factored a polynomial? Pretty simple, and we've kind of talked about this a decent amount, but none of the other factors can still be broken down. So you always just have to keep double checking to make sure that nothing can be broken down. So none of the other factors, that's an A, can be broken down. So as we go through these at the end of each problem, I'm going to be asking, can this be broken down further? Are there any perfect squares, difference of squares? Are there any sum of cubes, difference of cubes? Are there any trinomials that can be factored? We just got to make sure we're double checking that. Okay. So let's do number 6 here first. Right, you had to do the evens. Right. So looking at this first one, we have a difference of cubes, or excuse me, a sum of cubes. So two perfect cubes on either side, separated by addition. So A cubed come on now, there we go, equals 64C cubed. And we have B cubed equals 1. In order to get A and B by itself, we need to take the cube root of each side. So when we do that, we will end up getting A. So we need to take that of both sides. So cube root of this side, cube root of this side, cube root of B cubed, cube root of 1. And we end up getting B equals cube root of 64 is 4. Cube root of C cubed is C. And then we have, sorry, that's supposed to be an A. My apologies. And then B equals 1. All right, so now we have A and we have B. So if you look back up at the top here, right, this is a sum of cubes. So we're going to be plugging it right back into this here. All right, so whatever we have for A, we plug in where we see A. Where we have B, we plug that in for B. And make sure you keep an eye on the squares. All right, I'm going to put all my answers in the left column since we're not using these, okay? So here we go. A is for C, so 4C plus 1 times 4C squared. Okay, so we need to put A squared, so 4C squared. So 4 squared is 16. C squared is C squared, yeah, C squared. We need to do both, okay? Not just one. Both of them need to b squared minus 4c plus 1. Now, when we look at this, we just got to make sure that this cannot be factored any further, all right, and it cannot here. So this is our final answer. I will go ahead and box that answer. All right. Next problem here. When we look at this problem, let me scroll up to it. When we're looking at this problem, first thing we need to look at is, do we have perfect cubes? Okay, 54 is not a perfect cube, all right? So that's an issue. But if you notice, we do have a GCF. It's the first thing we always need to check first. And it says that right there at the top if you look in the instructions, okay? So let's take the GCF out. The GCF is 2. Again, I'm going to use the other column if I need to here. I can't zoom in. So the GCF equals 2. So when we pull the GCF out, we put that on the outside. 54 divided by 2 gives us 27 x cubed plus 250 divided by 2 is 125 y cubed. All right. So now, once we've taken the GCF out, as I've said many times, we are looking specifically inside of the parentheses. All right, so that 2 is going to be on the outside for the rest of the equation, all right, for the rest of the time. So when we do this, a is going to be a cubed. Excuse me. We now have perfect cubes. A cubed is 27 x cubed. B cubed is 125 y cubed. All right, taking the cube roots of both sides, since they are perfect cubes. So, therefore, A equals cube root of 27 is 3. Cube root of x cubed is x. B, cube root of 125 is 5. Cube root of y cubed is y. So now we have A and B. We need to plug that back into the equation. So A plus B. Now what happens to this 2? This 2 needs to come to the outside since it's our GCF. So we can't forget that. All right, just always check to make sure you have a GCF or didn't have a GCF. All right, in this case we do. So 3x plus 5y times. All right, so let's look back at the top here. A squared is 3 squared is 9, x squared. Multiplying, all right, so we have minus a times b. 3x times 5y gives us 15xy, and that's minus 15xy. And then finally we have b squared. B squared is 5y, so it's 25y squared plus 25y squared. Last thing we always have to do is double check to make sure there's nothing else that can be factored. In this case it cannot, so we're going to box our answer. And we are done. Number 10. Do we have a GCF? First thing we always have to check. Yes, our GCF is AB squared. All right, we see that we have 7 A's on the left, 1 on the right side there. All right, so each of the terms has A's. The lower exponent is 1, so A. And as I said, B squared, we have 2 B's on either side, so they both share the common factor of B squared. All right, when we take that out, we end up with a B squared parentheses A to the 6th minus 1. All right, now focusing inside of our parentheses. So we have both perfect squares and we also have both perfect cubes, and they're both a difference. So what should we do? Should we take the difference of squares or should we take the difference of cubes? If you have to choose between the two, take the difference of cubes. You want to take the bigger one, okay? Otherwise, it won't fully be simplified. You would have to simplify it further. So to reduce the amount of steps that we're doing, you would be taking the difference of cubes. So a cubed here equals a to the 6th. B cubed equals 1. Take the cube root of each to simplify. Get a by itself. Take the cube root of each to simplify and get b by itself. We end up with a equals a to the 2nd. We just divide by 2. And then here we get b equals 1. All right. Now that we finished that, go ahead and cross this out. We need to plug these in. Don't forget that we have a GCF. Let's put that on the outside. A, B squared on the outside. Parentheses. We have a difference of cubes here. So we're going to go up to the difference of cubes. A minus B times a squared plus ab plus b squared. So a minus b, a is a squared minus 1. And if you're looking at that right away, you can see that we have a difference of cubes there, so we're not going to be done with that. We're going to have to simplify this further. All right, and then going back up to the top, for the difference of cubes, you can see that the rest of them are addition signs. So a squared. So when we square a is already a squared, so that will end up being a to the 4th plus ab plus a squared finally plus 1. And as I said before, we have a difference of squares here. So we take the difference of squares. AB squared times a plus 1, a minus 1, a to the 4th plus a squared plus 1. There's our final answer. All righty. At this time, I'd like to call out one of our sponsors, Snickers. Hungry? Why wait? Grab a Snickers. All right, number 12. Here we go. The first thing we need to look at is, you guessed it, GCF. So, GCF. What is our GCF here? GCF, if we look at that, we get 9y as our GCF. All right. When we divide this out, we end up getting 9y outside of parentheses, since it's our GCF. Inside of parentheses, y to the 6th. 9 divided by 9 is 1. Y to the 7th divided by y to the 1st is y to the 6th. Minus 16. 144 divided by 9 is 16. So we get y to the 6th minus 16. All right, in this case here, do we have a difference of cubes or do we have a difference of squares? Looking at this, you should be able to tell that we do not have a difference of cubes because 16 is not a perfect cube. Therefore, we need to do the difference of squares. So, a squared equals y to the 6th. B squared equals 16. Taking the cube root of both sides here to get a and b by itself. Do not need to put cubes there. They're squares. That's my mistake. All right. So, a equals y to the 3rd. when we take the square root of y to the 6th, it's divided by 2. We get y to the 3rd, and the square root of 16 equals 4. All right. So there we go. We have everything we need. This is a difference of squares, so it's not going to be the same thing that we've been doing. We're looking up here. This is our difference of squares formula. All right, so let's go ahead and plug that back in. What do we have to put on the outside? Our GCF. So our GCF is 9y times a plus b times a minus b. So y squared plus 4, or excuse me, y cubed plus 4 times y cubed minus 4. Now, question is, are we done? Let's look at this right here. This is the one that we have to be concerned about. We have a perfect square here. We have a perfect cube here. All right, but this one is not a perfect square, and 4 is not a perfect cube. Therefore, we can't simplify that any further. So we are all done. Same thing goes for the other one. Okay, we don't have a sum of cubes because 4 is not a perfect cube. It's a perfect square. So just be careful when you're checking those out. All right, let's go to the next page here. Let me scroll. Number 14. All right, so we talked about this. When we look at this right here, we have a fourth power, we have a second power, and we have no variables here whatsoever. Okay, so in this case, if you look back at your notes, all right, we know that our first variable in our two binomials, because this is trinomial factoring, we're going to have two binomials being multiplied to each other. All right. And again, because this is a fourth power here, all right, we know that our first term is going to have to be multiplied together. It's going to be w squared and w squared. So we're going to start out by putting w squared in parentheses. And how do we know that? We can also look at our middle term and see that that's squared, and we know that that's going to be our first term. All right. So we do everything as normal. I'm going to take 32 here. It's a negative 32. What two factors multiply together to get negative 32, but add together to get negative 14? That would be negative 16 times 2. All right, negative 16 times 2. If we add them together, we get negative 14. So that matches what we have right here. Therefore, those are our two factors. So w squared minus 16 and w squared plus 2. Are we done? No. We have a difference of squares right here. All right, so we need to finish that. W squared is w, so it's w plus 16 squared is 4, w plus 4, w minus 4. Again, just using our difference of squares formula. A squared is w squared. When we square them both, we get w. So a is w, and then b would be 4. Therefore, we're plugging that in, and we have to finish up by putting the back factor in, w squared plus 2, which cannot be simplified any further. Therefore, it is our final answer. All right, going to do a few more of these. Let's look at number 16. Number 16, you can tell that each of the terms has at least one a, so we know we're going to have a GCF with an a in it, but we also notice they're even numbers. So 2a is our GCF. We're going to divide everything by our GCF and put it on the outside. So we end up getting a squared plus 14a plus 48. Looking at 48, let's see if we can simplify this. 48. Two factors of 48 that add together to get 14. 8 and 6. 8 and 6 multiply together to get 48, add together to get 14. So those are our two factors. Here we have a squared, and our middle factor is a. So we know that what we're going to end up having is a as our first term, as our first factor for our two binomials that we'll be creating. All right, so 2a goes on the outside, and we have a plus 8 and a plus 6. All right, at this point, going over a bunch of problems. This is a review that we had. I'm going to post the rest of the answer key. If you have specific questions about the answers to those problems, make sure that you email me at it's bryanarchbishopcurley@gmail.com. That email, again, is specifically for questions that you guys are asking about the assignments. That way I'm not having questions mixed in with the assignments that are rapidly being turned in by the hour. So there's a lot coming in right now, so just please help me out by forwarding your questions to that Gmail email I just told you about. Again, I'll write it right here. Bryan Archbishop Curley. Whoa. At Gmail. And that is for questions. And I'll do my best to get videos out to you guys. As you ask questions, I'm going to upload them to my new YouTube channel, which I will be just sending you the links directly. All right, now let's get started with the lesson. All right, so today we're solving polynomial equations by factoring. You guys are actually familiar with this. We've already done this basically, but now we're just using our special factoring that we've been given. And today is the day that we introduce imaginary numbers. All right, imaginary numbers. Not a lot going on with imaginary numbers. I'll explain it as we get there. Just know that if you square root a negative, that's impossible in the real world of numbers. But in our case, we're going to create imaginary numbers so that we can solve these. We're not just going to put the answer as undefined, okay? So we need to solve each of these by factoring. So you've seen something very similar to this before. Coffee break. So let's look at the steps. Number one, move all terms to one side and set the equation equal to 0. Okay, so we're going to move all terms to one side and set the equation equal to 0. We're going to want to move them to one side and get it into standard form, put it in standard form. Number two, it says factor the polynomial completely. Again, make sure you factor it all the way. Don't just factor it once and say, oh, it must be done. Always check to see if you have any trinomials that can be factored, different to squares, different to cubes, sum of cubes, etc. Right? Or GCFs, of course. All right, always checking GCF first. All right, so let's look at number one here. Oh, and then it says 3, set each factor equal to 0 and solve for each x value, just like we did for our zeros. Right? When we found our zeros, we did the exact same thing. We set each factor equal to 0 to find what our zeros would be, which is where, again, the line of the graph crosses through the x-axis or bounces off of the x-axis. All right, so for number one, all right, it says move all terms to one side and set the equation equal to 0. This one is already equal to 0, so we don't have to move anything to the other side. Factor the polynomial completely. Number one, we always check for a GCF. Our GCF here is x. So GCF is x. We're going to factor that out, put that on the outside, and we're left with x squared plus 1. All right, x squared plus 1, and that equals 0. All right, so now we have an equation instead of just an expression, so we have to solve for this now. So we have two factors here. All right, factor 1 is right there, all right, as x, and factor 2 is x squared plus 1. We can tell that they are factors because they are being multiplied. Right? Factors are terms that are being multiplied to each other. All right, so when we factor this out, we get x times x squared plus 1 are two factors. We need to set each of those equal to 0. So first, x equals 0, and we also have x squared plus 1 equals 0. All right, x equals 0 is done for us. We have our answer, x equals 0. So we'll go ahead and box that one. And then this one, first thing we need to do is subtract 1 from both sides. So we get x squared equals negative 1. All right? And in order to get x by itself now, as we have done many times, we need to take the square root of both sides. If it was x cubed, we'd take the cube root of both sides. If it was x to the fourth, we take the fourth root of both sides. It's x squared, so we're taking the square root of both sides to get x by itself. Uh-oh, we have a problem here. We are squaring a negative. All right, so anytime we square a negative, all right, you're going to deal with this as if it was just a positive number, except that you need to take out an I, which stands for an imaginary number. We're not really sure what that number is. All right. In this case, the square root of 1 is just 1. So the square root of negative 1 is going to be I, 1I. All right. But remember, everything is plus or minus when we take the square root of something. So this will end up being x equals plus or minus 1I, or just I. All right. So if we are taking the square root, I'll just do an example here. It's just kind of a side example. Square root of negative 4. All right, we would end up getting plus or minus 2I. So you see, if we have a negative, we just need to make sure that we have that imaginary number out there, which is, again, just I. And we're going to go over plenty more of these examples. If you have questions, again, make sure you forward those to me. I'll try to give you some videos that may explain this in a different way, maybe give you a different perspective that will help you out. But we will be doing plenty of these. All right, so number 2, step 1, keep looking up the steps. You notice this is kind of what I'm doing. I'm going up and just checking the steps each time as I go through these, making sure that I'm doing everything I need to do in order to get this problem right. So move all terms to one side and set the equation equal to 0. So looking at this one here, we want to get the right side equal to 0, so I'm going to subtract 3x from both sides. So minus 3x squared, 3x squared, minus 3x squared. All right, and we're left with 4x cubed. And we had like terms, which is why I put it under there, minus 10x squared equals 0. All right, now we have that side equal to set to 0, so now we have to factor the polynomial completely. All right. So we're looking at this. Do we have a GCF? We absolutely do. Our GCF is 2x squared. So I'm going to put the 2x squared on the outside. And we are left with 2x minus 5 on the inside. And that equals 0. All right. Can this be factored any further? No, it cannot. Very nice, very nice. My wife's doing a puzzle. She's doing a great job. Really great job.
Thanks.
All right. Oh, man, this stuff is crazy. I love it. I love it. It's fun. All right, here we go. Let's keep going. So, we cannot factor this any further. How many factors do we have? Good job, Ricky Gons. 2 factors. You're absolutely correct. All right, so we have those 2 factors. We need to now set these equal to 0. So we have 2x squared equals 0. And then the other one is 2x. In fact, I'm going to erase this so that I have more space. I will get better at this as we go. 2x squared equals 0 as our first one. And you can see I'm separating them just so I can kind of keep track of them here. 2x minus 5 equals 0. And we're going to solve for both of these. All right, first we need to divide by 2 here. Right, when we divide by 2, we end up getting x squared equals 0. All right, then we take the square root of both sides to get x by itself. All right, x equals, we don't need to do plus or minus 0. There is no plus or minus 0. 0 is a neutral number. All right, so this is just going to be x equals 0 in this case. All right, if we had x squared equals 1, if we had x squared equals 4, when we take the square root, you just got to remember to have plus or minus. Unless we're doing it with 0, all right, we don't have plus or minus 0. So there's our first answer, x equals 0. And then our next one, we have to add 5 to both sides. Just doing basic algebra here. And we end up getting 2x equals 5. Divide both sides by 2. Divide both sides by 2. And we end up with x equals 5 over 2. And that is our second answer. So we have 2 answers here to solve for this. And There they are, x equals 0, x equals 5 over 2. There's a better way to write these out. I'm kind of running out of space here. I'm going to have to end this video and start a new one.